Unit 3 discussion topic, modeling data. In this discussion, we'll explore the use of a linear and exponential function to help us model data. We'll explore the use of two mathematical equations to describe the relationship between year and the percentage of high school seniors who apply to more than 3 colleges. The time period of interest runs from 1980 to 2016. The data are shown in this bar graph. So along the x-axis, we see the years, 1980. There's not the same number of years in between, but there are 7 different years represented. And along the y-axis, it shows us the percentage of high school seniors that applied to more than 3 colleges. Two functions have been proposed to model the data. The first is a linear model, f of x equals x plus 31. And the second model is an exponential model, g of x equals 32.7 times base e raised to the 0.0217 times x. And both of these functions, f of x and g of x, represent the percentage of high school seniors who applied to more than 3 colleges x years after 1980. So the variable x represents the number of years since 1980. For this discussion, you'll select one of the years shown in the bar graph, use both functions to determine the percentage of high school seniors who applied to more than 3 colleges x years after 1980. Let's work an example. In 2019, which is not shown on the graph, 72% of U.S. high school seniors applied to more than 3 colleges. Let's determine which of the two models, the linear or exponential, is a better model for 2019. So 2019 is 39 years after 1980. How did I get that? I took 2019, subtracted 1980, and I got 39. So I'm going to evaluate the linear model when x is 39, and I simply replace x in the model with 39, and I come up with 70. So this model says 70% of high school seniors would apply to more than 3 colleges in the year 2019. Now let's do the exponential model, again when x is equal to 39. Now I'm going to pull up the calculator. I'm going to let you see the calculations here, but I'm also going to pull up the calculator. And remember, we saw base e both in Unit 2 discussion when we did continuous compounding, and we also learned about it in this unit when we learned about exponential functions. All right, so what do? We work on the exponent first. So we start over here, and we're going to take 0.0217, and we're going to multiply that times the 39. So that's our exponent. Now remember, on this calculator, which I actually showed in the Unit 2 discussion video, the base e is a second function. So I'm going to hit second, and I notice it comes up down here. When I hit that key, this number is the number of base e raised to that power. You can see that right there, and I put that here in the slide. And then I'm finally going to multiply by 32.7, and I come up with about 76.22. All right, so in 2019, the actual number was 72%. The linear model gave us the percent as 70% when x is 39, and the exponential model gave us the percent of 76.2% when x is 39. So again, 72%, this is the actual value, not calculated from either model. So the question is, which function is a better model for these data? And I'll let you answer that when you do your discussion posting. So your assignment, you're going to select one of the years shown in the bar graph, and you're going to answer the following questions. According to the linear model, f of x, what percent of high school seniors applied to more than 3 colleges in the year you selected? Remember, x represents the number of years after 1980. So you're going to have to calculate the value of x for the year that you selected. Question 2, according to the exponential model, g of x, what percent of high school seniors applied to more than 3 colleges in the year you selected? And then finally, which function is a better model for the data shown in the bar graph? Explain.